Welcome. In this video, I will show you step by step how to set up a .NET benchmarking project. We're going to start with a blank slate, create our project. We're going to be writing two methods that we're going to benchmark, and those methods are going to be different ways of concatenating strings. And as you know, in .NET, depending on how you do that, that can have a performance impact. We're going to be using a package called benchmark.net. I'm going to show you how to use it, a few of the attributes, the APIs that are available to us with that library. We're going to actually run the benchmarks. I'll explain the results, some of the things that, those statistics that will be coming up, what they mean and how useful they are, and also how to get an actual report output that you can use and share and store somewhere else if you want to. All right, so this should be fun. Let's dive right in. I will share my screen, and we're going to be doing this, like I said, with the CLI, the .NET CLI. Actually, let me make that full screen. There we go. So, and I'm going to be using VS Code, but if you're using Visual Studio or another IDE, this should all be applicable. I'm actually not sharing the right thing here. Too many of them opened at the moment. There we go. And full screen. Okay. So the first thing we want to do is we're going to install a template, a .NET template that's provided by that package, benchmark.net. So .templates, yep, I already had it installed on my machine, but if you didn't, it will install it with that command. Now we can create our actual project, and I'm just going to create a project without a solution, keep it really simple. But obviously what you would want to do in a real practical situation where you want to benchmark, methods from maybe an application or a library that you have, you'd probably just create that new benchmarking project inside of your existing solution. But for this demonstration, we're going to keep it real simple. Okay, so benchmark is the name of the template. There's a few flags here that we can add. We're going to make this a console app. We're going to run this on the .NET 6 framework, and we're going to output to a string benchmarks folder, which will by default become the name of our project as well. All right, so that seems to be working. Let's open up VS Code. Actually, I got to cd into this first. What did I call it? String. Yeah, that's the one. Now I can open VS Code in that directory. Here we go. Let me walk you through quickly what the template has set up for us. The program file, right? This is an actual console app. So with a main method that simply runs our benchmarks using the benchmark.net package. And we have a benchmarks class that's set up as well, where the actual things that we want to benchmark, the benchmarks that we want to run, are going to be located. Notice the benchmark attribute here above those methods. That's what's telling the benchmark.net package that these methods are special and they need to be benchmarked. One thing I will do here, if you're following along in VS Code, you'll want to, if you don't already have that, you'll want to install and enable the C# extension. It's going to ask you to set up some stuff. Just say yes, and we're all ready to go. Let me just bring my terminal back up here. Okay, so there is one thing we're going to do And first, before we start actually writing our tests, or not tests, sorry, but our actual methods that we want to benchmark, we're going to add an attribute here. Yeah, Copilot is awesome, called memory diagnoser. And I guess I'm missing. It should be provided in attributes, I believe. Let's just do, no, that should already have been done for us, but let's see. String benchmarks. Okay, maybe that was just it. Small blimp here. No, still complaining. Memory diagnoser. Okay, I know what I'm doing wrong. This was, I was putting it on top of the namespace. It needs to be added to, yes, there we go. Okay, this will just add some information to the output, the benchmark output. That gives us information about memory. So, you know, how much garbage collection is happening, and basically how much memory is being used by each of the benchmarked method we're going to be benchmarking. All right, so very simply, what we're going to benchmark here is different ways of concatenating strings. So what we're going to do is build a string. So our method's going to be return a string. And if you read the documentation for benchmark.net, they do suggest that your benchmark method ideally return something. And that you shouldn't, if you're dealing with, for instance, enumerables, you want to, you know, get a concrete collection, convert it to a concrete collection first, to have your benchmark be more meaningful. Okay, so let's do return string.join, right? We're gonna simply we're gonna build a string that's going to be a series of numbers, right? An incrementing series of numbers. So that'll be really simple. So starting with 0, 1, 2, 3, 4, 5. So that's going to be our string. So we're going to join, okay, and it's going to be comma separated. And we're just going to use the range enumerable, I believe. Yes, but let's just keep it small for now. I'm going to start with 5. So 0, 1, 2, 3, 4 is what this is going to be doing. We need to, yeah, that's not, there we go. And we also need to using, there we go. We need to, yes, that's exactly what I wanted, right? So we need to convert that into a string. And that will give us the string that we want. Great. So that's our scenario 1. Now, as you know, concatenating strings, or you may not know, but yeah, concatenating strings naively in C#, like for instance, just using the plus operator, right? One can do 0, oh, well, yeah, and then like that. But that creates 2 strings, really. Actually, that creates 3 strings because we've got that first string, the second one, and then it'll create a new string that contains, you know, both of those, that concatenates those. And that's expensive in terms of memory and all that. So there is a class that we can use, a type that we can use in built into the framework. The language that's called string builder, and that's what we're going to try to use to see if we can get better performance compared to the other method, on which, you know, this is really nice and concise and clean looking, but as is often the case, abstractions like this come with a cost, and we're going to see exactly what that cost is. So we're going to create a new string builder, and we need the using for that. Okay. And what we're going to do now is use a for loop. We're going to start at 0, so that we need to make sure that we're getting the same output as the other one because we're comparing it, right? And as long as I is smaller than 5, we keep going. Yes, and see, Copilot knew where I was going with this. Append I, and the same kind of separator. So the strings we'll end up with are going to be identical. I need to make sure that I'm returning a string here and returning, I believe it's simply toString, yeah. Okay, so there we have it. Really simple for our demonstration here, but we have two different methods that essentially do the same thing, but in a different way. And we want to see what is the performance difference between the two. So in order to run your benchmarks, it's really easy. You simply do .NET run. You just need to make sure that you're passing in the configuration flag of release. You don't want to be running your benchmarks in like a debug build, right? And also, one thing to note, I'm running this benchmark. Let me start it, and I can keep talking because this takes a little while. So I'm running this right now inside Visual Studio Code. I've got my recording software open. I'm recording audio and video. I've got notes on the side. I've got like a bunch of programs, as you can see from the bottom bar. Oh, I guess you don't, but I have a bunch of programs open, and that will affect the accuracy of your benchmarks. In our case, it's fine. The difference between the two implementation you will see is big enough that the margin of error is not going to be a problem. But if you're dealing with like benchmarking things that have a slight difference in performance, well, then you really want to close everything down and run this from a terminal. So if you're in Visual Studio, for instance, shut down Visual Studio and run this benchmark from the terminal. You'll get more precise result. All right, so we're done. And what do we see here? This was actually pretty quick. I'm surprised. Benchmark, yeah, we didn't. Okay, so yeah, okay, so we've got both of our scenarios here, and this is really interesting. Scenario 1, which is, I'm expecting to be slower, was actually slower. But it used a little bit less memory, right? It allocated a bit less memory. So I didn't expect that. I was expecting the string builder to use less memory, but the string builder was significantly faster, as you can see. Okay, so there's two things we're going to change here and rerun this. So first of all, let's make the names a little bit more meaningful. That'll make it easier to compare them in our output here in the terminal. So let's change that to, let's just say string join, because that's essentially what we're using. And here we're going to call this one string builder. Is it going to complain? No, that should work. Okay. And the other thing I'm going to change here, you can do in benchmark, you can pass in as a parameter baseline equals true. And this will add just 1 or 2 columns to our report that gives us basically a percentage difference between our baseline and the other test. All right, so let's run this again and see what we get this time. Seems to be running pretty quickly, so let's have some fun with this a little bit. And yeah, so that's interesting. So faster, but it does use just a tiny little bit more memory, apparently. Let's see if this is the case again with this test run. Feel free to speed up the video for this part, or I might do that in post, but maybe not. We'll see. Okay, so here we go. Yeah, same thing, right? It's using a little bit, the builder's using a little bit more memory, but it is significantly faster. This is what putting something as the baseline gets you. So you can see that our string builder is 60% the time of our string join. So basically a 39% faster, I guess you could say, performance in this case. It is useful to look at the margin of error, right? Because if you look at the mean and you take, let's say the slowest one, you remove 0.767 from it, and you add from the fastest one, the margin of error, 701. In this case, we can see that statistically speaking, even taking into account the margin of error, the two results are well, they're apart from each other. So statistically, we can really say that string builder is faster, but it happens sometimes that you'll have a slight performance difference. And when taking into consideration the margin of error, there's an overlap. So in that case, statistically, you really can't say that one of the two methods was faster. All right, let's take this up a notch, and I'll show you another nice feature from that benchmark.net library. So we're only doing 5 concatenation basically here, right? Let's see if we get a different kind of result when we're doing it with bigger numbers, right? If more numbers to concatenate. And what we can do is we can actually use parameters to run different versions of our benchmarks. And that's what we're going to do. So what we can do here is add a prop, and we're going to, it's going to be an int. We're going to call it just n, and and this is where we can add params. And now, of course, we can, add a bunch of them, but you have to keep in mind that this will, for each param, you get an extra benchmark run. So it'll increase significantly the time that it takes to run these benchmarks. So let's just do 5, which is the case we're doing right now, 50 and 500, right? So that means it'll take probably 3 times as long to run our benchmarks now, but that's fine. And okay, so instead of hard coding the 5 here, we're gonna do n, and the same thing here. We're going to do n, all right? And let's run this again. So it'll run each of these methods with each of the params that we've put here, 5, 50, 500. And it'll be interesting to see if the string builder is still faster with higher number of appends, right? And also if the memory profile is still the same. Remember, with 5, string builder took a little bit more memory, right? There was a bit more memory that was allocated using the string builder. Will that be the case when we're dealing with 50 or 500 appends? I have a feeling that the string builder will be using less memory in that case, but let's see what the benchmarks tell us. Right. Okay, so yeah, let's just finish. Let's just wait for this to finish, and then we can analyze our results. So while this is running, right, normally, just to make this very, very clear, normally you wouldn't be writing your implementation inside your benchmark class, obviously, right? You'd probably bring in from your other assembly, your other package, reference, whatever, your actual code, and you'd be exercising that inside of your benchmark function. Okay. I will put in the video description a link to the package benchmark.net. There is a bunch of configuration that you can do there. You can add categories to your benchmarks. You can filter it in different ways. You can actually run just a subset of all of your benchmarks using CLI flags. So there's really a lot that you can do. I'm just showing, and we're just scratching the surface here, but that what I'm showing you is enough to get you started with some basic benchmarking scenarios. All right, here we go. So you see how the output has changed now. We've got our N parameter here. So in the 5 run, right, we've seen this result here, and it's similar to what we've seen so far. We're using more memory, but we are about 40% faster. Now, looking at the 50, okay, so here we're still around 40% faster, but now, as we can see, we're using less memory with the string builder. In a bigger scenario, we're actually even faster. Now we're at about 50% faster, and we are using almost half the memory. So we can see a bit of a trend here. No doubt if we would have tried 5,000, it would have kept going with that. These here are the garbage collection. How many garbage collections per... Now there's usually there's a legend for those here. For some reason it's not showing up right now, but yes, basically there's just different generations of garbage collection. The lower the better, usually, and you can see that except for the first case, because we're using more memory, we're doing less garbage collection. Well, I guess not quite in this case, but it's so small that it's really inconsequential. So there you have it. A simple way to benchmark anything you want, really. Last thing I will show you is that the benchmark.net package will output, of course, from in your CLI, the results of the test, but also in a benchmark.net .artifacts folder, there is a subfolder called results. And by default, it will output a, okay, so you have it in text format. That's basically a dump of whatever was shown in the CLI, right? It's exactly the same. So there's that in text format if you want, but more readable report format is provided with a HTML, CSV, which you could, plop into Excel if you wanted to, and Markdown, which can be really useful if you're doing a pull request. After doing some benchmarking, you can just copy paste that into your pull request comments with GitHub, for instance, and that would show nicely. Let me show you what this looks like. Okay? Pretty nice. All right. That's about, yeah, I think that's going to be it for this video. I hope you found it useful. If that is the case, please like or subscribe. I will try to put out videos like this a little bit more frequently going forward. So if you want to be, aware of when they're coming out, that's going to help you.